All right. And we should probably change this to reflect. Okay. This is the worksheet that you have in front of you. And I want to go ahead right now and kind of walk through a few pieces here. A couple of things. This is all review for you. You should have some semblance or remembrance of this. Okay, so here's what I want. I am going to call on Millie to tell us what the independent variable definition is. Okay, you all may help her. You have 3 minutes. Go. Or I hold you all at recess. Okay? You've got to work as a team and draw from prior knowledge. See if you can remember. Okay, so we've got something. The word variable means... So it's got to be something that changes. What thing? Okay, it's more to it than that. It's more to it than that.
You don't change the dependent variable. It changes with like the other.
Okay, Colby's onto something.
The dependent variable changes as you experiment on things.
Okay, say it louder, Reagan, or tell Millie so she can tell us.
What?
Tell Millie so she can tell us. No. That what?
That you change. Yeah. I told you guys that changes.
That you forgot.
No, you said it stayed the same.
No, I said the dependent variable.
Shh. All right. That was very good. It is the variable that you choose to change. Okay? That's absolutely right. You choose to change it. All right? Now, the abbreviation for this is going to be IV. And it can also be known as the manipulated variable. The manipulated variable, it's the thing that you control. Let me give you an example of what I mean. Okay? First of all, independent means I, or can equal I if we're independent, equals I. I change it. Exclamation point. I am in control. All right. Let's say that we're doing an analysis of different woods that a beetle eats. Okay? So let's say that I put 5 beetles, 5 of them, in 4 separate containers. So that's a total of how many beetles? Yes? 20 beetles. Okay? 5 beetles in 4 separate containers. And in each container, I put a sample of wood. Okay? So in one container, I put no wood. We'll get to that in just a minute. In the other 3 containers, I put 3 different types of wood. All right, so I'm going to draw this for you over here so that we can kind of use this as our example for this morning. I have these 4 containers, and in these containers, I'm going to put some beetles. Five, and they're red. Okay? And in the first one, I put no wood. And the second one, I put that type of wood. And that one I put that type of
Right diagonal and left diagonal.
that type of wood. And in this one I put
Circles.
that type of wood. Kind of does. All right. So I've got 3 different types of wood. What is the independent variable here? What's the thing I am manipulating? I am changing. Emma. The wood. I have control over what wood goes in which container. That's the what. That is what I am controlling. I am in charge of the wood. There it is. It's fantastic. The lines, the axes, and the circles. Fantastic. Okay? Now, the dependent variable. What would that be? Yeah. The thing that I can't control, but I can indirectly manipulate. I'm going to get to that in just a minute. So I'm going to do this in a different color. The dependent variable. Obviously, it is something that changes in the experiment. And it has to change because it's a variable. It's something that changes in the experiment depending on the independent variable. Okay, so I'm just going to say it's something that changes in the experiment over which I have no control. Over which I have no direct control. I know this seems kind of confusing, this dependent variable, okay? But here's kind of what I mean by that. I'm testing which woods beetles eat or how much they eat, okay? So, in theory, I can kind of determine ahead of time that in the first container, how much will they eat? And nothing. There's nothing to eat. So even though the independent variable is the type of wood and I put no wood in there, I know the outcome. The outcome is they're going to eat no wood. Okay? And the second one, okay, I can, depending on what type of wood in there, I can predict what the outcome is going to be, and the same in the third and the fourth. Okay? Now, do I have direct control over the beetles, their mouths, and their digestive systems? I do not. However, I can kind of influence what they're going to do by indirectly putting different types of wood in there. So there could be thousands of woods to choose from. I pick 3 that I know will produce some kind of result. So indirectly, even though I can't control what they're eating or how much they eat, I can control a little bit of the outcome by setting up my experiment a certain way. Okay? Now, this is the thing we usually measure. It's the thing that as a scientist we have to be careful about. Let's say we're doing fireworks, right? And I am doing an experiment on the amount of gunpowder in a mortar. Okay? The amount of gunpowder. Now, the amount of gunpowder is going to be the thing I change. I can predict that the probably more gunpowder means bigger boom, okay? So, even though I can't control the boom, even though I can't control the boom, I can kind of influence it, right? I can add more gunpowder, and I know that's going to create a bigger boom. I just don't know how much bigger that boom is going to be. That's why I'm going to measure this and then write it down. The thing I physically change, more gunpowder. The thing I measure, boom. Okay? I know that there's a relationship there, but I don't necessarily know the direct outcome. That's why it's called a dependent variable. I can influence it, just not directly. Okay? I can't say it's going to be a 5 megaton boom. Okay? You are only allowed to do 5 megatons, not 5.10. Okay? Any extra boom, and I'm just going to stop the experiment mid-boom. Okay? Can't do that. You got to let the experiment go through the process and hope for the best. All right? Mid-boom, that means, oh, stop there, no more boom. Okay? Yeah, exactly. Done. No more. Okay? No, you got to let it go. Okay? Case in point, had a friend when I was growing up, lived down the road from me, and didn't know much about gunpowder and the way it behaves. Didn't realize that if he dropped a match in a gigantic container of it, the outcome, he knew he could affect this. He knew that if he dropped the match in there, it would go boom. But he had no direct control over how big the boom was. He is, even though he lost all the skin on his face. Okay? I did. Yes. Just have to let it grow back on its own. Oh, yeah, he's fine now. Yeah, but I mean, when you're looking at him and he's missing 3 layers of skin and it's all raw tissue, yeah, it's pretty terrible.
He's still 12 years old and his skin hasn't come back. He hasn't aged at all.
What is a lesson to be learned there? You should have some idea of what the outcome is going to be like, okay, and take every precaution because you don't know in an experiment what it's going to do. Okay, you just don't know. Yes.
Well, he wanted to look down to see if he dropped it in the huge bucket.
DV, okay, and you should also know this is called the responding variable. The responding variable. It's the variable that responds to whatever it is that you have changed. Okay? The best way that I can kind of describe these two things is cause and what? Effect. Cause and effect. All right? Okay, so in the second box here, we could also say, what's it going to do? Question mark. And the answer is, it depends. It depends. Dependent variable. It depends on how you change the experiment. Okay, the next part. I don't necessarily like very much the terminology of this part here. Controlled variables. Okay? I'm going to get rid of the word, not that. I'm going to get rid of the word control, or variables, excuse me. Why would I do that? These are things that what? Yeah.
Change. Wait, what? No. The controlled variables are things that you control and they most likely stay the same.
Exactly. Things I control but most likely stay the same. Okay? So the word variable is kind of misleading. They are called controlled variables. So therefore, we are going to use the abbreviation CV. Okay? But what you should understand here is this, that they do not change. It is something we set up. We can kind of think of it as a parameter. Okay? All right, so something can only happen within certain parameters. I'll give you an example. You can only grow within certain parameters. Okay? You only are going to grow to within a certain height. You're only going to grow within a certain width. You're only going to grow within a certain age. There are parameters that naturally are in place, okay, for human growth. So most humans do not live beyond 120 years. Most humans do not grow above 8 feet tall. Most humans do not grow outwards of more than 8 feet. Okay? Just putting in a realistic parameter.
What?
Shh. I have not experienced that. Shh. I'm thinking of all humanity. Okay? All humanity. I want to account for every possibility. So there are parameters, things. Well, in an experiment, you have to keep certain things the same. Okay? You have to set up parameters. So if I am testing, let's say, the amount of sleep of someone, or of sleep of people, I'm going to put them all in the same type of mattress. I want them to lay down and try to go to sleep at the same time with the same light conditions. If they have some kind of music playing, I want to make sure the music's playing for all of them that is the same. I want to make sure that all of the things that could influence the outcome of the experiment, that I'm limiting as many things as possible. So, these are things that we try to keep the same in an experiment. I'll just say things. I don't like that word so much, but things. Another name for these is constants.
Oh, we used that word last.
Right. All right, and the best thing I can say is these are things that have to stay the same throughout the experiment.
What cup of coffee is that?
You look at your schedule and you say, what period am I in Mr. Bornhammer's classroom? The period corresponds to the cup of coffee.
Wait, that last time you had like 6 cups.
Not true. Not true.
Yeah, it is.
Evidence,
It was 4.
proof, word of mouth, secondhand, hearsay.
So you're saying if you have one each period, you have 11 cups of coffee
This one's
while
done.
you're at school.
Say what?
So you're saying you have 11 cups of coffee while you're at school. Yeah, we don't.
8.
Oh my gosh.
It depends. No, I stop about lunch.
Still like 6.
Hey,
It's just unhealthy.
just the first week of school. Then it goes down by like 10%.
You have a cup of coffee.
And then that's 5.5 coffee.
All right, we're getting off track. Control group. Explain to me this. Control group. Erica.
It's the group that you want to like keep normal so you can see the change.
Right, it's a group, excuse me, that receives no change. Wow, I can't spell receives. Thanks. I before E, except after C. It's a group that receives no change. So there really is no independent variable. Okay? And because there's no independent variable, we can pretty much predict the outcome. So which of my canisters or objects on the board over here, which one of them would be my control group? Colby. The first one. There is no independent variable. There is no wood. And because there's no wood, I know that the beetles will eat nothing. And because I know they're going to eat nothing, that's the baseline. So, if the beetles die within the first day in this group, I should expect that these beetles will die within the first day. If they don't, then maybe the wood has prolonged life-preserving features. Hence, I don't know, food.
Or those beetles just have to be older than those, or they'll.
Well, I want to make sure that all the beetles come from the same crop. So I would have raised them all from worm.
What if one?
Actually, I guess you don't really call them worm, you call them, well, you can call them worms. Larvae.
I got Ebola and the other ones
Great.
died.
Well, I don't know. So,
Wait, would the control group be like the one that you give the sugar pill to?
yes.
Yeah, but there's 5. So
Yes, so the control group in human experiments, especially medicine, would be like the placebo group. The group that is receiving what they think is the real thing, but really is just like a sugar pill.
What if they like are those people that exaggerate and they're like, oh.
Well, that's why we have a control group, right? Because every group is going to have that person that's like, oh my gosh, I don't know if that was okay. In the back of your head, you're thinking, you just had sugar. You didn't even have the real thing. He's like, I'm going to die. And you're like, dude, you didn't even receive the real medicine. You don't tell him this. You just watch it all unfold. Recorded, of course, for documentation. Hypochondriac. Okay? So a control group that receives no change. The best thing I can say is it's a group that you know the outcome for. All right, last but not least, let's go with gray. All right, the experimental group. The group or groups that receive change. Okay, basically these are the groups that are going to have an independent variable manipulation. Okay, e.g. Okay. Is it coming back to you a little bit? I would hope so. If not, there's a reason we go over it 2 years in a row, because I think it is important. One of the things is, as I can tell you right now in high school, you'll talk about this possibly, but it actually comes in handy if you're going into like college. So Mrs. Bornheimer and I, we both are taking master's classes, and one of the things that she had to do was take a research class, and in that research class, she spent a lot of time analyzing research for kids in reading. That was the experimentation, right? And she had to analyze independent variables, dependent variables, groups that were controls, experimental groups where they tried different techniques. This was all for reading, helping kids read better, right? Experiments like this don't happen just in a scientific laboratory. There are social and psychological experiments as well, like in classrooms. Okay, so when we're going through this kind of breakdown, we should understand that it doesn't just apply to biology, chemistry, physics, etc. It applies to the way that we run or interpret any sort of experiment. Now, here's what I want you to do in the next minute or so, couple minutes. I want you to try to answer these two questions. Why is it important to design an experiment that has these parts? That's what it means by controlled experiments. Okay, and what is the purpose of having a control group and an experimental group? Why do you have to have both? Why can't you just have an experimental group? Why can't you have just a control group? So take a moment and just write down some of your ideas. Okay, I will give you, let's say, 2 minutes. And then I'll have you share them with the people around you. Millie.
This is irrelevant. Did you meet Mrs. Bornheimer in college?
I did meet Mrs. Bornheimer in college. Yep. I was a sophomore and she was a junior. No. She is. I'm a youngin'.
You look like a 50-year-old man.
Watch it. Be careful there, boy.